Welcome to a new video for sequences, Arithmetic Cambridge, how to find the nth term. If you're preparing for paper 4 in the coming days, so you must know how to find the nth term for different sequences. Let's move forward. First of all, to get the nth term of any sequence, you must know what type of sequence first, then we're going to work on the formula for the nth term. As you see here, we have sequences are listed, the types of them. The first one is the arithmetic, then we have the quadratic, then cubic, rational sequence, exponential sequence, and geometric. Today we're going to talk in this short video about the first three types, arithmetic, quadratic, and cubic. And you must know the formula of the nth term of each of them. The arithmetic, it's a n plus a. In the quadratic, it's a n squared plus bn plus c. In the cubic is a n cubic plus bn squared plus cn plus d. What you need to know is you need to know the values of a, b, and here a, b, and c, a, e, b, c, and d, and n is the order of the term. N can be 1, 2, 3, and so on, but n must be an integer. So I'm going to move to the questions. We're going to start with an example here, how to find the nth term of the following sequence. As I said to know, we need to know the type first of the sequence before we do anything. And we must be aware of some patterns of the numbers, such as what? We must know the even numbers, we must know the prime numbers, odd numbers, square numbers, cubic numbers. So you must be aware of them. If we're going to list the odd numbers first, 1, 3, 5, 7, 9, and so on. These are the odds. And we have here then the even numbers, 2, 4, 6, 8, 10, and so on. Prime numbers, 2, 3, 5, 7, 11, and so on. The square numbers, 1 squared is 1, 2 squared is 4, 9, 16, 25, and so on. Cubic numbers, 1 cubic is 1, 2 cubic is 8, 27, and we have here 64 and 125, and so on. Why do I'm listing these numbers? Because we're going to compare later on the given sequence with one of these patterns to reach to the formula. But first of all, let's find the type of the sequence. To know the type of the sequence, you're going to see the common difference, or the term to term rule, what's going on. Here, if you're going to find, we add 3, then we add 3, then we add 3. So they are all same common differences, adding 3. Whenever you have the same common difference from the first time, so it means you have arithmetic sequence. The formula of the nth term is an plus b. What's a and what's b? A is the common difference, or the term to term rule, what's going on. B is the zero term. What do I mean by zero term? We're going to see now. The common difference in here is 3, so it's going to be 3n. Zero term, this is T1, which is the first term. There's T2, second term, and T3, then T4. So to know here the zero term, instead of adding every time, you would get back one step. It will be minus 3. So 2 minus 3 is negative 1. So this is the T0. Again, how to get the B or the zero term? You're going to see what's the pattern going on. You're adding, so you will do the opposite in here. If you're subtracting, you will do opposite in here. So the zero term is negative 1. So to the 3n minus 1. You want to make sure that your answer is correct. You're not sure about what you got. You can replace the n by 1, then by 2, then by 3 to make sure that the first three terms are correct. And as I said to you, that n must be an integer. So let's make sure that our answer is correct. What we will do is we're going to replace the n by 1 first. So if you replace the n by 1, 3 by 1 is 3, minus 1, it's 2, which is correct. Replace the n by 2, 3 by 2 is 6, 6 minus 1 is 5. Replace it by 3, 3 by 3 is 9, minus 1 is 8. So n is the order of the terms. If n is 1, it means first term. If n is 2, it means second term. If n is 3, it means third term. Okay, so this is regarding the first one, which is the arithmetic. If we move to the second one, let's check what's the type. we're going to see that here we subtract 8. We subtract 8. We subtract 8. So they are all same common difference. So it's going to be what? It will be here arithmetic as well, which is the formula an plus b. A is the common difference, which is minus 8. And b is 0 term. So instead of subtracting, I will do the opposite here. So it will be 88. So the 0 term is 88. You can make sure by replacing n by 1 and by 2 by 3 to get the first 3 terms. If they are the same here, you are correct. Negative 8 by 1, it's negative 8, plus 88, it's 80. Negative 1 by 2 is 16. Negative 16 added to 88, it will be 72. The negative 8 by 3 to the negative 24 added to 88, it will be positive 64. So here's the formula. It can be written as 88 minus 18 as well. Both of them are correct. This is regarding the first type. And we must memorize the patterns in here because we're going to need them. Now, let's see this time. We're going to check here. First of all, we added 3. Then we added 5. Then we added 7. So you're going to say that they are not the same. So what you will do, you're going to check between the common differences what happened here. So you added 2, then you added 2. So you found that the second common difference is the same. So whenever you are checking the common difference between the numbers in the sequence, and you find that the second common difference is the same, it means you are working with a quadratic sequence. Second common difference is the same. How to get the nth term for this? Here is a long formula, but we're going to take a short way. What I will do is, I'm going to compare the given numbers here by the square numbers. So here we have the first number is 1 squared, which is 1, then 2 squared, which is 4, 3 squared, which is 9, then 4 squared, which is 16, and so on. So why do I'm using the square numbers? Because this is quadratic sequence. It means it will have n power 2. So now we wrote the square numbers. Let's compare it with this here. This is 2, this is 5, this is 10, and here 17. So it means, what did we do? It means we squared this number. We squared the 1, then we added 1. So 1 squared is 1, then we add 1, it will be 2. We squared the 2, which is 4, then we added 1. We squared the 3, which is 9, then we added 1. We squared the 4, which is 16, then we added 1. So it means you are having n number, you squared it first, then you added 1. So this is the nth term by comparison with the square numbers. You can make sure 1 squared is 1 plus 1, it's 2. 2 squared is 4 plus 1, it's 5. Then 3 squared is 9 plus 1, it's 10. 4 squared is 16 plus 1, it's 17. So this is the nth term. Regarding point B, let's do it in here. We're going to see here we do what? We add 1, then 3, then 5. So they are not same common difference, so it's not arithmetic. Then we here add 2, then we add 2. So this is quadratic, the same as this one. So once you have realized that it's quadratic, so what you will do is you're going to compare these numbers with the square numbers pattern. So it will be a 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, and so on. So you just compare the main one here, 0, and here 1, here 4, and here 9. Notice something in here. It's 1 and 0, 4 and 1, 9 and 4, 16 and 9. It means that these numbers are squared, but they are less than these here. So in this case, what did we do is, when we square the 1, it becomes 1. So how it becomes 0? So it means we squared, then we subtracted by something. It's n squared, or n, you can say n minus 1 squared. So because 1 minus 1 is 0, 0 squared is here. Then 2 minus 1, it will be 1. 1 squared is 1. Then 3 minus 1 is 2. 2 squared is 4. Then 4. 4 minus 1 is 3. 3 squared is 9. So if you notice the difference here, here we squared, then we added off. Here we subtracted first, then we squared. So what did happen is, if you can remove the line in the middle, you're going to find that you first of all did what? You subtracted 1. 1 minus 1 is 0. 0 squared is 0. 2 minus 1 is 1. 1 squared is 1. 3 minus 1 is 2. 2 squared is 4. Then 4 minus 1 is 3. 3 squared is 9. So we subtracted, then we squared. So here is the answer. If we move to the cubic, welcome back for part 2 of the PDF sequences. How do you figure out the nth term of a sequence? We already started last time about the types of sequences, and we have done the arithmetic, the quadratic, and we have done the cubic. So now we're going to move to the rational sequence and the exponential sequence. We can avoid doing the geometric in here. So we work, and actually the exponential and geometric, they are a bit close. So we need to focus on the rational and sequence, the exponential. If I'm going to talk about the rational, what's the nth term for the rational? The rational is a fraction. You have a over b, and then, for example, a added to something and b added to something, or subtracted, and so on. The sequence goes on in this pattern. So what you need to know to get the nth term, or to figure out the nth term of the rational sequences, you're gonna take separately the numerators alone, all the numerators in the given pattern. For example, it is a plus something, or subtracted a plus double this thing, and so on. So you're going to take the numerators all, you will try to figure out the nth term for all the numerators, and you will do the same thing for the denominators. So you will take separately the numerators, and you will take separately the denominators. You will try to get the nth term for this one and the nth term for this one, then you will put them above each other in a fraction form. For example, if the nth term here is n minus 1 and the nth term here, for example, is n squared, so the general nth term for this sequence, the rational, will be n minus 1 over n squared. We're going to work on examples now to discover how to get the nth term for the rational sequence. If I move to the exponential, how to get the nth term of the exponential. How do you know it's exponential sequence? You're going to find the relation, or the term-to-term rule is multiplying by number or dividing by a number. For example, you have 2, then you have 8, then you have, for example, 32, and then 128. So if do you notice here, we are not adding. This is a big gap between adding. If you're going to try to check if it's arithmetic, quadratic, or cubic, you will not find the common differences are coming the same. So it's clear that we are multiplying here by 4, and here by 4, and here by 4. So once you realize, or you figure out that it is multiplication between the terms, it means you are working with exponential sequence. So how do you get the nth term? Focus very well in this part. What you will do is you're going to write the first term as it is, multiplied by. Here, what's happening is we are multiplying by 4 every time. So you will write the first term multiplied by the term-to-term rule, but then we need to know what's the power of the 4. This is what we're going to talk about later on in the coming examples. So the exponential, the nth term will be what? Will be the first term multiplied by the ratio, or the multiplication which is going on in here. Then you will try to find the power. This is what we will work on the next example. Let's see examples here to clarify what we are doing. If we move to this question, it says find the nth term of the following sequences. In part A, as you see here, it's 2 becomes 6, then 6 becomes 18, 18 becomes 54. So what did happen if you add and check 2, here we added 4, here we added 12, then we added, and so on. So it's a big gap. So you're going to notice we are multiplying here by 3, then by 3, then by 3. So since you are multiplying, you are working with exponential sequence as we mentioned before. So it will be here. What you will do, you're going to write the first term multiplied by what? Multiplied by the term to term rule. What's term to term rule? It says we are multiplying by 3 every time. Then we're going to see what's the power. So if the first term here is 2, we're going to drop it in here. Then we have 3. But you try to imagine with me. 2 times 3 power what equals 2. 2 times 3 power what equals 6. 2 times 3 power what equals 18, and so on. If we go to the first one, it's 2 times 3 power what equals 2. It means the 3 has been removed. When the 3 would be removed? When it has power 0. So the first term can be represented by what? Can be represented by 2 by 3 power 0. This one can be represented by 2 times 3 power 1. Here, 2 times 3 power 2. Then 2 times 3 power 3. Now we're not done yet. We need to get a relationship between the powers in here, because this is the most important. Here we can write the rule of n, as you know. 2 and 3 will be the same, they will not be changed, but the power will be changed. Now, n, 0, 1, 2, and 3, this represents n, these numbers, the powers in here, or the exponents, they are representing n. But notice something from the previous video. What did we say? We said n must start with 1, not 0. So n it's supposed to be 1, here it's supposed to be 2, it's supposed to be 3, it's supposed to be 4, the power, not 0 and 1, 2, and 3. So what did happen in here? Because the 0, so what did we do to remove the 1 and put 0? What did we do to remove the 2 and put 1? What did we remove to make the 3 as 2, the 4 as 3? We subtracted 1 from each value. So it means you are having n, but you subtracted 1. So again, what do? We write the first term, then we write the term to term rule, which is the multiplication. Then I do work on the powers. What's the relationship between the powers? Here we have what? The power is 0, the power is 1, 2, and 3, but n it must start from 1, not from 0. It must start, and this must be 2, 3, and 4, and so on. So what did we do to make the 1 0, the 2 1, the 3 as 2, the 4 as 3? We subtracted 1. So this is the nth term. You can even try to make sure that you understood. Here, replace the n by 1. So it will be 1 minus 1 is 0. 3 power 0 is 1. So 2 by 1 is 2. Then replace the n by 2 because this is second term. So 2 minus 1 is 1. 3 power 1 is 3. 2 by 3 is 6. Then you can replace the n by 3. So it will be 3 minus 1 is 2. 3 power 2 is 9. 2 by 9 is 18. Then you can replace the n by 4 because this is the fourth term. So 4 minus 1 is 3. 3 power 3 is 27. 27 by 2 is 54. So the rule is correct. Let's try one more example because I'm sure that the exponential, maybe you'll not get it from the first time, so you need to do more practice. In B, we have 1, then becomes 2, 2 becomes 4, 4 becomes 8. So we added 1 here, then we added 2, then we added 4. So it means this will not be arithmetic, will not be quadratic, will not be cubic. So once you notice or you figure out that we are multiplying in here, so it means we are working with exponential sequence. So what do is we write the first term, which is 1, multiplied by the term to term rule, which is 2. Then we need to see what's going on here. Let's suppose it's 1 times 2 power something. Then here, just let's remove this to clarify what we're doing exactly. So this is the first here. We have 1 times 2 or something, then 1 times 2 here, 1 times 2. So 1 times 2 power what equals 1? 1 times 2 power 0. Here 1 times 2 power 1, 1 times 2 power 2, then 1 times 2 power 3. So we need to get a relationship between the powers as well we did in the previous example in here, 0, 1, 2, and 3. The power of the 2 here, it must start from 1, not 0. So the 1 here, and 2 here, and 3 here, and 4. So what did we do is, we subtracted 1 each time. So the power will be n minus 1. You can write this simply as 2 power n minus 1 only, the nth term, because 1 multiplied by anything, 1 is the multiplicative identity, so it will not affect, it will be 2 power n minus 1. If you want to make sure your answer is correct, you can replace n by 1, then n by 2, then by 3, then by 4. If you get the first 4 terms as what's given in the question, so you are correct, you can just do a quick substitution in here for the values of n. If we replace n by 1, 1 minus 1 is 0, 2 power 0 is 1. Then if we replace the n by 2, 2 minus 1 is 1, 2 power 1 is 2. If we replace the n by 3, so 3 minus 1 is 2, 2 squared is 4. If we replace the n by 4, 4 minus 1 is 3, 2 power 3 is 8. So our answer is correct. This is regarding the exponential sequence. Now we're going to move to the rational sequence. As I mentioned in the beginning of this video, how to find the nth term of the rational sequence, what you will do is you're going to take the numerators all as a separate sequence. You try to get the nth term for them. And the same thing in here, you will do for the denominators as well, as consider them as separate sequences. So if we take the numerators first, 5, 6, 7, and 8, let's figure out what's the type of the sequence. You're going to find we're adding 1 in here, then we're adding 1, then we're adding 1. So this is arithmetic because we have all common, they have the same common difference. The rule was an plus b. So a is the common difference, which is 1. 1 will not be written, so it will be n. Then b is the 0 term. So if this is the first, every time we're adding 1, to get the 0 term, we'll subtract 1, so it will be here 4. So the b is 4. So the rule is n plus 4. Every time we are adding 4 to the n. So this is the nth term of the numerator. Let's get the nth term of the denominator, then we put them above each other. If we take the denominator here, 18, 19, 20, and 21. If you notice, we're adding 1 every time, so this is arithmetic sequence as well. So it will be an plus b. So a is 1, it will not be written, it will be written as n. Then if I want to get the 0 term, which is b, I will get back one step by subtraction. It will be 17. So the 0 term is 17. So it will be n plus 17. This is the nth term of the denominator. So now to get a common nth term for the complete sequence, it will be n plus 4 over n plus 17. If you're not sure about your answer, you can just do substitution, replacing n by 1 to get the first term, and replace the n by 2 to get the second term, and then by 3, then by 4 to make sure that you have the first 4 numbers, so you can make sure that it's correct. So if we replace the n by 1 in the first one, replace the n by 1, 1 plus 4 is 5, 1 plus 17 is 18. If you replace the n by 2, 2 plus 4 is 6, 2 plus 17 is 19. If you replace the n by 3, 3 plus 4 is 7, 3 plus 17 is 20. If you replace the n by 4, 4 by 4 is 8, 4 plus 17 is 21, so the nth term is correct. If we move to the next one, 7 out of 8, 8 out of 16, and 9 out of 32, 10 out of 64. This was in November 2020. Paper 4, variant 2. Let's see how to do this. We're going to take the numerators together as sequence. You're going to find 7, then 8, then 9, then 10. We're adding 1 every time, so it's arithmetic. Then, so how to get the nth term to be an plus b? 1 will not be written here, so it will be n. To get the 0 term, you will get back one step by subtraction. It will be 6 in here, so it will be n plus 6. This is the nth term of the numerator. The problem is not in the numerator, the problem is in the denominator. How to get the nth term of the denominator, because you're going to consider it as a separate sequence in here. So 16, 8, 16, 32, 64. What do you notice is we are multiplying by 2, multiplying by 2. So if we are multiplying by 2, as I told you before, it means it's exponential sequence. So what you will do is you're going to write the first one in here, the first number multiplied by 2. So it will be 8 multiplied by, or just we can do something more simple. Let's try this first, then we'll try something else. 8 times 2 power 0, then 8 times 2 power 1, then 8 times 2 power 2, then 8 times 2 power 3. 8 times 2 power 0 it will be 8, 8 times 2 power 1 is 16, 8 times 2 power 2 is 32, 8 times 2 power 3 is 64. So we can agree on the nth term would be 8 times 2 power. Here you have power 0 and power 1, power 2, then power 3. So the n must start from 1, not from 0. So it's here 1, here 2, here 3, and here 4. So what do we do to make the 1 as 0, to make the 2 as 1, to make the 3 as 2, to make the 4 as 3? We subtracted 1, so it means there was n here minus 1. But it's not done yet. Here is one more step in this question. What's the new step we will do? As we know all, the 8 is 2 to the power of 3. Here, 8 is 2 power 3 multiplied by 2 power n minus 1. We have started in the indices that what should we do when we have similar bases and multiplication? We do add the power, so it will be 2 to the power of 3 plus n minus 1. So it will be 2 to the power n plus 2. This is the nth term of the denominator. But we do this case only in case of the first number in here can be, can be replaced by a number which is having a power with the same base. Because 8, it can be 2 to the power of 3, which is having the same base as 2. So it will be 2 to the power of n plus 2. So now we got the numerator's nth term, and we got the denominator's nth term. So we can write it as one complete nth term. It will be n plus 6 over 2 to the power n plus 2. You can just replace the numbers in here. If you get the answers, it will be more perfect if you do it just substitution, so make sure your answer is correct. So it will be here. Replace the n by 1. It will be 1 plus 6 is 7. Then replace the n by 1. 1 plus 2 is 3. 2 power 3 is 8. So it's 7 over 8. If you replace the n by 2, it will be 2 plus 6 is 8. If you replace the n by 2, 2 plus 2 is 4. 2 power 4 is 16. If you replace the n by 3, it will be 3 plus 6, which is 9. If you replace the n by 3, 3 plus 2 is 5. 2 power 5 is 32. For the last one, it will be, you can do just 3 of the first terms to make sure the answer is correct. Here we can replace the n by 4 because this is the fourth term. It will be 4 plus 6, which is 10, and 4 plus 2 is 6. 2 power 6 is 64. So our answer is correct. You can do the substitution for the first 3 terms is enough, and you must remember that n is the order of the term. So when you are trying to find the first term, you replace n by 1. If you are trying to find the second term, you replace n by 2. If you are trying to find third term, you replace n by 3. So here we can do something better for finding the nth term of the denominator. Okay. This is another trial to find the nth term of the denominator. If you notice here, 8, 16, 32, and 64, they are all, like the powers of 2. 8 can be written as 2 power 3, 16 can be written as 2 power 4, 32 can be written as 2 power 5, and 64 can be written as 2 power 6. So if you take them here, it's 2 power 3, 2 power 4, 2 power 5, 2 power 6. So it means you have 2 as a base. Then you're going to check the powers. The power is here. The power is 3, 4, 5, and 6. As we know, n must start from 1, not 3. Must start then 2, then 3, and 4. So what did happen to the 1? So it becomes 3. What happened to the 2? It becomes 4. What happened to the 3? It becomes 5. What happened to the 4? To become 6. It means we added 2 to each n to reach to this power. So it means 2 power n plus 2. So this can be another way of how to get the denominator, or how to get the nth term for the denominators in a rational sequence. Now we're going to move to one question from the past papers, a complete question on the past papers about the sequences. In this question, this one of the past paper questions, the question says the first 4 diagrams in a sequence are shown, diagram 1, 2, 3, 4. The diagrams are shown using white squares and gray squares. You can complete the shape in here. The first one, it says diagram 1 is having 12 white squares and 0 gray squares. The diagram 2 is having 20 white and 1 gray. Diagram 3 is having 28 white and 4 gray squares. If you notice what we are doing exactly in this one, we're adding 8. So if you add 8 here, it will be 36. To get the nth term, this is arithmetic sequence since we are adding the same number. So it will be an plus b, which is a is the common difference, which is adding 8. Then the 0 term we should get back by subtracting 8. Instead of adding, it will be 4. So it's 8n plus 4. This is the nth term for the first one. For the second one, it's 0, then 1, then 4. If you remember from last time, in the previous video, what did we do? We said, I will try to figure out what type of the sequence is it. So if you notice, we're adding here 1, then we added 3. The difference between them is 2. Since I reach it to the second level of common differences, it means I'm working with quadratic equation. So in quadratic equation, we must compare the numbers which I'm having in the pattern with the square numbers. So if you are having here 0, then 1, then 4, just compare it with the square numbers. 1 squared is 1, 2 squared is 4, then 9. So what you will notice is here the 0 squared is 0, then the 1 squared is 1, then the 2 squared is 4. So here it is 0 squared, 1 squared, 2 squared. This is 1 squared, this is 2 squared, then this is 3 squared. It means we subtracted 1, then we squared. The n is supposed to start from 1, not from 0. So what did happen? We subtracted 1 from the n, then we squared. N minus 1, then we squared, like what we said last time. So if you try to do it in here, the first term here, n is 1. 1 minus 1 is 0. 0 squared is 0. N is 2. 2 minus 1 is 1. 1 squared is 1. Then if n is 3, 3 minus 1 is 2. 2 squared is 4. If n is 4, the fourth diagram, so 4 minus 1 is 3. 3 squared is 9. So the remaining here is 9. And the nth term is n minus 1 whole squared. If we move here to part 4, diagram 4, the nth term is given, so I just need to replace the value of n by 4 because this is the fourth term. So this part will be 4 plus 1 multiplied by 4 plus 5. 4 plus 1 is 5 multiplied by 9. So the missing in here is 45. If we move to question B, in question B it says, work out the number of the diagram which has a total of 480 squares. So if we're talking about the total, here the total number of the squares would be using this nth term. Work out the number of diagram which has a total of 480 squares. Total, it means we're working here. If I'm asking you to work out the number of the diagram or the order of the diagram, so you need to find the value of n. What you will do is you're going to use the nth term and make it equal to the given number, which is 480. We just need to expand. It will be working with algebra in here. So it will be n squared, then plus 5 in here, then plus 6n all equals to 480. Then just do it in here, n squared plus 6n. Then you put the 480 on the left-hand side. So we'll just do 480 minus 5. It will be minus here 475. Then we do factorization. First, let's use the calculator. 12a. Then we would mode, then 5 equation, then 3 because it's quadratic. We put the 1 here, n is 1, the a is 1, and the b is 6. And then negative 45, negative 475. So n is 19 or negative 25, and for sure we don't accept negative for the order of the terms. So the n is 19. So the term that has the order 19, this is the term that has a total of squares, gray and white, 480 squares. Let's see part C. Part C, it says the total, and it's already highlighted here, the total number of squares in the first n diagrams is going with the rule 1/3 n to the power of 3 plus p n squared plus q n. Use n equals 1 in this expression to show that p plus q equals 11 and 2/3. Then use n equals 2. Then find p and q. You must understand something. It says the total number of squares in the first n diagrams. So it means if you have the first diagram, you will get the total for this one. If then you have the second diagram, when n is 2, you will get the cumulative addition for the first and second. Like, for example, when n is 1, you will get the total of squares in diagram 1. But when n is 2, you'll get the total of squares in diagram 1 plus diagram 2. This is called cumulative addition. If n is 3, you will get the total squares of the first diagram, the second diagram, and the third diagram. So why I'm doing cumulative addition? Because it's mentioned here at the head of this question, the total number of squares in the first n diagrams. It means the first, when n is 1, so the first one. If n is 2, so the first 1 and 2. If n is 3, first, second, third, adding together. So just let's do it in here. If n is 1, we will replace the n here in this equation by 1. So it will be 1/3 by 1 cubic plus p by 1 squared plus q by 1. If we remember, the first diagram was having the total number of 12 squares, because I'm talking about the total. So I will equate this with the 12. Then I will try to simplify it. This would be 1/3 plus p plus q equals 12. Just shift the 1/3 to the other side. It will be p plus q equals 12 minus 1/3. It will be 11 and 2/3, which is mentioned in here. In part I, it says use n equals 2 in the expression to show that 4p plus 2q equals 30 and 1/3. So how to do this one? Since n is 2, as I mentioned before, we will get the total of the first diagram added to the total of the second diagram. Total of squares in the first added to the total of squares in the second, because the first n diagrams means adding cumulatively. So just replace the n by 2 in this form. It will be 1/3, 2 cubic plus p by 2 squared plus q by 2, then equal to what? Equal to the total. Let's get back to the previous slide. The total of the first is 12, the total of the second is 21, so we can add them together. So it will be 12 plus 21. Here it will be 33. And here we can complete substitution. This is 8/3. And this one is 4p plus 2q. It will be 4p plus 2q equals 33 minus 8/3. So it will be 4p plus 2q equals to 30 and 1/3, which is required in this. In part I, it says find the values of p and q. You have in the first star, you have p plus q equals to 11 and 2 over 3. At the double star, or these two stars, you have 4p plus 2q equals 13 over 3. So we're going to solve simultaneous equations. It will be p plus q equals 11 and 2 over 3. And here we have 4p plus q equals 13 over 3. I'm not going to go further in this part how to do the simultaneous equation because it's not my topic now. So what I will do is I'm going to solve them on the calculator. We can press mode, then 5, then 1 to get the simultaneous equation. Then you're going to have 6 places in here. The first one for the coefficient of p, coefficient of q, then the answer. The fourth is for the coefficient of p, fifth is coefficient of q, then the answer. So what we're going to write is here, the first, the coefficient of p is 1, then the coefficient of q is 1, then the last answer is 11 and 2 over 3. You can just write it as mixed number better. So it will be 2, 11 and 2 over 3. Or just we can change it into improper fraction. It will be 3 by 11, 33 plus 2, 35 out of 3. So 35 out of 3. And the second one, we have 4 coefficient of p. Then we have 2 as a coefficient of q. Then we have here 3 by 30 is 90 plus 1, 91 out of 3. So we can write 91 out of 3. So the x is 7 over 2, or the p is 7 over 2, and the q is, so here 7 over 2, and the q is 49 out of, just check with the calculator for the final answer, 49 over